be similar to triangle PQR in this case if the corresponding sides or the corresponding angles are equal. Corresponding angles are equal. Corresponding angles are equal. That is, if I take that is angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R. Then these two triangles are similar. Similarity sign is that triangle ABC is similar. This is similarity sign to triangle PQR. Now these two triangles are similar. The corresponding angles are equal. Okay. In that situation, the two triangles are similar. If we have proved that okay, these angles are equal. Both this angle is 30 degree. This is 30 degree. This is 60 degree. This is more than, or this is 90 degrees suppose, or right angle triangle in that situation. Okay. Or each angle is 60 degree, 60 degrees equal, and it's all 60 degree, 60 degree, 60 degree. So these two triangles are similar, but these sides are different. This is about 6, 6, 6. The 2, 2, 2. It can be 1, 1, 1, 4, 4, 4. But sides are not equal. That way they are proportional. Okay, in that situation, if the given two triangles are similar, if given two triangles are similar, or we have proved that they are similar, then their corresponding sides are proportional. Then their corresponding sides are proportional. Or we can say that we have taken angle A is equal to angle P. So the opposite sides of this is BC, here is QR. This BC upon QR must be equal to, then we take B angle equal to Q angle. So side opposite to these are AC upon this AC upon PR. Then we took angle C equal to angle R. So side opposite to them is AB upon QR. No, this PQ. Yeah, PQ. Now, one thing which is to be remembered is this: that whatever corresponding angles we have taken, undoubtedly, this angle is equal to this, then opposite sides of them is this and this. If in one ratio we have taken the side of this triangle, the smaller triangle side we have taken above in the numerator, and the corresponding side of the bigger triangle we have taken in the denominator, then the same position is to be maintained throughout these three ratios. What is that? That in the numerator, the smaller side of the the smaller triangle side will come. For example, here I have taken PC, AC, and AB. Good. It must be maintained. We cannot say that if BC upon QR is there, then here we have taken PR upon AC. That means the largest triangle side we have taken in the numerator. In the denominator, the smaller one. Then the ratio will not be proportional. They are not then in proportion. We cannot say that. So this is to be maintained throughout. I mean, if smaller triangle sides are taken in the numerator or in the denominator, doesn't matter. If I have taken in the numerator, then it should be maintained in the numerator. All the three sides must come in the numerator, and in the denominator, the largest triangle sides must come. Okay. And if I have taken the larger triangle side in the numerator, then in the numerator, all the three ratios we have to take the largest triangle sides only. Okay. The denominator we have to take this proportional ratio must be maintained. This, fact must be maintained throughout the proportional ratio. This is fact in that situation. Corresponding sides are in proportion or in ratio. That ratio obtained by dividing corresponding sides of one triangle upon the other will be same, will be equal. Okay, so this is the condition in case of corresponding sides, and it can be in any way. The triangles are either acute angle triangles or right angle triangles or opposite angle triangles. That is not a matter of discussion, because all kinds of triangles are there. This is opposite angle triangle. This will also be opposite angle triangle. Shape will be similar. Shape will be similar, but size are not equal. This is not equal to this in size. Okay, every side is different. Having some ratio, proportional they are, but they are not equal. We cannot say that side PQ equal to AB, but this upon this equal to this upon this equal to this upon this. The ratio which is coming, that is maintained throughout. This is regarding similarity of the triangles. Okay, so this is something of similarity. Right. Now so similarity means when angles are corresponding angles are equal, then the triangles are similar, then we take their corresponding sides are in proportion. This is about similarity. Okay, in case of equilateral triangles, then is what? Question number 5 we have done. This is only 6th point. What are the basics of similarity of triangle? Now, when two triangles are said to be congruent, let me talk about this also. Congruency of triangles. Next point. This is the 7th one now. Question number 7th is congruency of triangles. Important facts regarding congruency of triangles. The congruency of triangles. This is question number 7. Congruency of triangles. That means two triangles are congruent or equivalent. This is solution we are finding out. Two triangles. Let me write here triangles in words. Two triangles are congruent or equivalent. They are known as also equivalent. Equivalent triangles or congruent triangles. Equal triangles, congruent if they are equal in all aspects. That is, their areas are equal. That is, they have equal areas. Okay. One thing is equal areas they have. The space occupied by them is same, equal. Whatever area or space occupied by one triangle is equal to the other triangle. What are the congruency conditions? Now, two conditions for congruency, let me write here. Conditions for congruency of triangles. For congruency of two triangles, let me take two triangles here, or maybe more than two triangles, but they are congruent if the condition is this. First condition is, we say, first condition S, side, congruency. This is congruency. What is side congruency? If the corresponding sides are equal. Okay. For example, the two triangles are, if you take these, the two triangles here. I am taking this PQR again. This is ABC. Here, AB is equal to, let me take PQ. BC equal to QR. And AC is equal to PR. These two triangles are congruent triangles. How to be right? And triangle ABC is congruent. This is congruency symbol of congruency. Okay, equal and similar is congruent to triangle PQR. These two triangles are congruent if the corresponding sides are equal. Okay, this side equal to this side equal to this side equal to this. Congruent triangles are having. This is first condition, SSS congruency. What is SSS congruency? We have just talked about. Next, second point is okay, SAS. SAS, no side, angle, side, congruency. This is congruency, side, angle, side, congruency. Okay, so this is another point. What is that? Let me talk about this. Congruency we are talking about. So second is, let's write here second, SAS, that means side, angle, side. One angle and two sides. At least three conditions must be satisfied. Either side, three sides are equal, or one angle and two sides, or two angles and one side. At least one side must be equal. Only then we can say congruent triangles are there. Otherwise, if we say angle equal, this is similarity condition that maybe or may not be in that situation. But if triangles are congruent, then they are similar also. But similar triangles may or may not be congruent. Vice versa is not. But congruent triangles are similar triangles also. Okay, that is one of the points. This is side, angle, side. For example, if I take the two sides here, these two sides, this one is equal to this side, they are equal. And this angle, included angle, is also equal to this A angle. This is PQR we have picked. In this situation, AB is equal to PQ, one side. Okay, then AC is equal to PR. Angle A is equal to angle P, one angle, included angle. The two sides, included angle of the two sides is also equal. This is SAS condition. Then two triangles are congruent triangles. Okay, in case congruency, the areas of two triangles will be equal in that situation. That is another point we will talk about. But for the condition for congruency, I am talking about. Third point is that if two sides are equal, okay, I have taken at least one side. Third condition is ASA, that is angle, side angle, side angle. At least one side must be equal. Okay, that means one side, if I take in two angles, let me take a triangle here. Okay, so these two angles are equal, and all these two angles are equal at the and one side, these two angles are equal. So these two angles, corresponding angles of a triangle, this one, this is equal to this angle, ABC, PQR, sorry, this is PQR we are taking. In this situation, this angle equal to this equal to this, these two angles are equal. And one side, and at least this BC equal to QR, if I have taken, and BC is equal to QR. One side is equal, okay, and two angles are corresponding angles are equal. Then also the triangles are congruent. Then ABC is congruent triangle. This is similarity. Congruent to triangle is a triangle ABC. Congruent to triangle PQR. Okay, so in this situation, angle B is equal to angle Q. Angle C is equal to angle R, and the side BC is equal to QR. Okay. So these are three conditions for congruency of triangles. What are the incongruency of triangles? What are the other facts regarding congruency of triangles? Let me just talk about that. Areas are equal. Ratio of the areas are equal, or areas are equal. Okay. In case of congruency of triangles, let me just marker. I have to change. Let me clean this. In case of congruency of triangles, we have to just talk about the condition for congruency of triangles. Okay, so all these congruency conditions I have talked about. What are the other facts regarding this? Okay, other facts regarding this, let me just note down them. Some points are still there. If that's what we talk about. Okay, in case of similarity, one fact which was remained in case of question number similarity. Okay, similarity. If there is a right angle triangle, let me take. There is a right angle triangle. This is the right angle triangle. Okay, this is right angle. Now, if I draw perpendicular from this right angle to the base of this, then these two triangles are similar to the original triangle. Let me take this as ABC. ABC here, this is D point here. This is right angle, this is right angle, this is right angle. Now, if I take this is theta angle, then it will be 90 minus theta. Okay, and this angle will be then theta in this triangle, and this is 90 minus theta. So what we see here, that if I take the original triangle, now in this case, this triangle ABD triangle, which is similar to triangle ADC, which is similar to original triangle ABC or BAC. So right angle is formed at angle A, which is a right angle triangle. ABC is a right angle triangle. A triangle ABC is a right angle triangle. Right angle at A. This is right angle, 90-degree angle. If I draw perpendicular from there to the base BC, then this is right angle, this is right angle. Right angle triangle, this is right angle triangle. So these two triangles, triangle ABD and ADC, are similar to the original triangle. This is how we can prove in case of similarity. Okay, similarity, a number of facts are there. That can be, this is one of the points students asked me. So what is this condition here? Now these two triangles are similar. They are not equivalent. We cannot say equivalent. Equivalent and similarity are different. In case of equivalent, now in this case these two triangles are similar, but they are not equivalent. And they are similar to the original triangle ABC. Okay, but they are not equivalent triangles. But in case of congruency, congruent triangles, the two triangles are equivalent in all aspects. The sides are equal, then areas are equal, angles are equal, everything. But in case of similarity, only angles are equal. In this case, this angle theta is equal to angle theta of this triangle. Okay, ADC and ABD, if I am talking about this angle theta, this angle theta, this is 90 minus theta, this angle is 90 minus theta, this is 90 degree, this is also 90 degree. These two triangles are similar, both corresponding angles are equal. Corresponding sides are taken later. And this is right angle, this is theta angle, this is 90 minus theta. In the original triangle also, this is complete 90 degree, this is 90 degree, theta, this is theta, this is 90 minus theta, this is 90 minus theta. So these two divided triangles, I mean triangles obtained after this perpendicular drawn, these two triangles are similar to the original triangle. They are not equivalent. So this is the condition here. This one of the points was left there. Let me. Okay, so this is regarding question number 6 I have talked about. Okay, now let me take congruency. There are certain other facts regarding the congruency here. So in congruency, we have just talked about congruent triangles are equivalent in all aspects. Okay, so ratio of the areas. In case of similarity, we have talked about that. In case of similarity, okay, area of equivalent triangles are equal. Okay, they are altitude. We can find out what is the height of. From that, we can find out the height or altitude of any triangle. That what is the height of this triangle, what is the height of that triangle. So congruent triangles are having equal areas. Okay, area of one congruent triangle is equal to area of other congruent triangle. Area of a congruent triangle. Two triangles are congruent. About this of a congruent triangle ABC is equal to, congruent means two triangles are congruent. Area of a congruent triangle ABC, congruent triangle ABC is equal to area of congruent triangle PQR. This is simple. These two triangles are congruent. One triangle cannot be congruent. Two triangles are compared and then they are congruent triangles because their sides are equal, their angles are equal, so their areas calculated will be equal. Congruent triangles are having equal areas. That is one of the points here. Congruency is this. Okay, so congruency is having not more things. Just regarding this is question number 7. Now question number 8, let me talk. Question number 8. What do you mean by the following quadrilaterals? Now let me talk about quadrilaterals here. Question number 8. Quadrilaterals. What do you mean by the following quadrilaterals? Number 1 quadrilateral is trapezium or cyclic. Okay, this is cyclic quadrilateral. We talk about cyclic quadrilateral. Cyclic quadrilateral. Cyclic quadrilateral. B point is trapezium. Okay, this is the trapezium. C point, let me take here a rhombus here. Rhombus. D point. After rhombus there is a rectangle. For the parallelogram is left. So after trapezium let me take parallelogram also. This is a parallelogram. Parallelogram. Let me write here O. This parallelogram here. Okay, parallelogram. We can write like this parallelogram. This is symbolically we write parallelogram. This is D point we have taken. There it is, C point, no problem. Rhombus, the rectangle and square. And then E point is rectangle. And finally F is sphere. These are the 5 kinds of, the six kinds of quadrilaterals we are taking here. We are talking about. First is cyclic quadrilateral. What is cyclic quadrilateral? Let me find out whether facts about cyclic quadrilateral. Now, if a circle can be drawn to all the 4 sides of a quadrilateral. Okay, so this is ABCD. Let me take. Now, if I take, okay, so this, let me draw this. Okay, this angle is equal to, sum of these two angles is 180 degree. Sum of these two angles is 180 degree. So cyclic quadrilateral, if all the 4 sides, this is 4-sided figures. Quadrilateral is 4-sided figure. If all the 4 sides of a quadrilateral are lying on a circle, that is known as cyclic quadrilateral. then if they are lying, or even if quadrilateral is drawn, condition is that the opposite angle sum is 180 degree. Opposite angle sum is 180 degree. Then we can say that that quadrilateral is cyclic quadrilateral. This is condition. When a circle, then the quadrilateral is a cyclic quadrilateral. Then the quadrilateral is a cyclic quadrilateral. Or we can say that if a quadrilateral is given, if we have found that opposite angle sum is 180 degree, sum of this angle plus this angle is 180, this angle plus this is 180 degree, then we can say that the quadrilateral so formed is a cyclic quadrilateral, because if we draw a circle, then the circle can pass through taking the center of this quadrilateral and taking center and radius from that point vertices can be circle can be drawn through passing through all the four vertices of a quadrilateral. Then the quadrilateral is formed. So the basic condition is that all the four vertices of the quadrilateral are lying on the circle. That is cyclic quadrilateral. This is first definition of this. But condition is what? That sum of opposite angles is 180 degree. Now we know that sum of all the four angles of a quadrilateral is 360 degree. Okay. Any quadrilateral, let me take any quadrilateral will have four sides. Four-sided figure is known as quadrilateral. Four sides. We have four sides, and sum of all the four angles of a quadrilateral is equal to 360 degree. Right, understood? Is equal to 360 degree. 360 degree sum. But in case of cyclic quadrilateral, the opposite angle sum is 180. Because in case of quadrilateral, any quadrilateral, sum of any two angles may be more than 180 degree, maybe less than 180 degree. Any two angles. Okay. But sum of all the four angles is 360 degree. That is fact about every quadrilateral. But in case of cyclic quadrilateral, this angle plus this angle, angle B plus angle D is equal to 180 degree. One condition. Second is angle A plus angle C is also 180 degree. Sum of all the four angles is 360 and outwards. But in this case, opposite angle sum is 180 degree. This is fact about cyclic quadrilateral. Okay, so cyclic quadrilateral is this, that sum of opposite angles is 180 degree. Now, because if I draw a triangle here, then this angle, okay, is equal to sum of these two angles. Interior vertically, the alternate interior, this angle plus this angle is equal to this angle. Right? So, and sum of these two angles is 180 degree. So sum of this angle plus this angle, sum of these three angles is 180 degree. Similarly, if I take here this angle, okay, this angle is equal to sum of these two angles, exterior angle of these two is 180 degree. Now, if I take sum of these two angles, therefore, okay, these two angles is equal to 180 minus angle D. These two angles is 180 minus angle B. Therefore, angle B plus angle C will sum of these two angles plus sum of these two angles. So, but angle, all the four angles is equal to 360 degree. And we can prove that sum of these two angles plus sum of these two angles is 180 degree. Angle B plus angle D will be then 180 degree. We can prove this. Okay, so that is there. That is a proof is in another lecture series or test questions based on all the formulae, based on all these kind of plane figures. These are the plane figures. We know two-sided figures. I mean length, breadth, areas, perimeters, etc. This is the plane geometry. we are talking about. Okay. In case of coordinate geometry, we talk about conic section. Conic section also I've taken here in the last question. Conic section, what are the parabola, hyperbola, ellipses, etc. I'll talk about them also, because they are part of a cone. If a cone is cut by a plane, and the plane is cutting a cone, then whatever the figure is obtained, it may be a circle, parabola, it may be ellipse, or it may be hyperbola. That three kind of figures are obtained by cutting a cone. Because of that they are known as conic sections. Okay, that we'll talk later. Question number 8. So we are talking about quadrilaterals. This is cyclic quadrilateral. The sum of opposite angles is 180 degree. So if I just take this angle, exterior angle, put sum of these two angles. This is angle 1, 2. Let me take this is 3 angle, 4 angle. Now, sum of these two is 180 degree, but angle this angle. Now I'll take this. After that, this is angle 180 minus angle B. Angle B is equal to angle 1 plus angle 2. Angle 1 plus angle 2 is equal to this angle, exterior angle. Take this is XBC. Angle XBC. Okay. Similarly, this angle YDA. Angle YDA. Angle YDA is equal to angle 3 plus angle 4. Okay, but angle YD plus this angle is 180 degree. Angle D, let me take this. Angle D, I'm taking this as angle D, this angle B. Okay, sum of these two is 180 degree. Angle D plus angle YDA. YDA is equal to 180 degree. Similarly, angle B plus angle XBC. XBC is equal to 180 degree. These two are equal, so this is equal to this. Okay, so angle B plus angle C, angle Y plus D, angle B, okay, plus angle this XBC. XBC here, angle XBC is equal to angle D plus angle this one, angle B D plus angle by DA. Angle by DA, but angle by DA and angle by C 1 plus 2, all these angles are taken. Okay, so this angle B, because sum of these two is 180, 360 degree.